Ducky, and we're going to be presenting some examples of data, analytics, and mining for our final project presentation. So here's an example of data pre-processing using North Brazil weather data from Kaggle. So before, there's a bunch of negative numbers and useless columns, and after pre-processing, a lot of columns have been dropped, and a lot of outliers have been removed.
In our second project, we went over the decision tree classifier. It allows us to make decisions based on previous sets of questions that were answered. The tree is trained and tested on a dataset that contains the one categorization. It is a great tool for data analysis because it can be used to predict future datasets. In this dataset, we were able to decide if the students were going to be admitted based on the input variables we received.
For classification models, we used the naive Bayes classifier, which uses Bayes' theorem and Gaussian probability density function to classify unknown values. And we also used decision tree classifier. As you can see, the decision tree got a pretty decent confusion matrix with very few false positives. And we get around 83-84% accuracy for both of them. We also used k nearest neighbor, KNN models, which uses Euclidean distance formulas to calculate the k closest known values to an unknown value in order to classify it. And we also use logistic regression, which is a supervised classification algorithm, to do the same thing. We were getting around 80 to 84% accuracy with these two models as well.
All right, so now I'll be looking at the ANN-based classification. Here, we used the admissions prediction dataset, and we binarized the chance of admittance by itself, as we're going to use that to predict and set a threshold of 90% to dictate 1, else it'll be set as 0. We then split the dataset and trained it to do a 20-80 ratio and reshaped the Y training and testing set. We then performed binary classification using cross entropy as a loss function. And with that, we were able to achieve 92% accuracy in the tested dataset.
Cluster analysis groups set of objects in such a way that objects in the same group are similar to each other than those in other groups or clusters. So as we have learned different clustering techniques in the class, we have implemented them in our project, starting with k-means clustering, which classifies unlabeled data into a predetermined number of clusters based on the similarities. And according to our observations, 6 is the number of clusters with which the sum of squared errors seems to be optimal. And to the right is the graphical representation. Moving on to the next slide, hierarchical clustering seeks to build a hierarchy of clusters, and here we are illustrating the dendrogram results on the right using 3 clustering algorithms. The single link, which is a method that focuses on minimum distances between clusters, and the second is a complete link, which concentrates on maximum distance, and the third is a group average, which computes the distance between the clusters using the average values. Thank you.
Text mining is an AI technology which uses natural language processing to transform unstructured text to normalized and structured data for further text analysis. It is mainly used to examine large collections of documents to discover useful insights and answer specific research questions. In our project, we made use of methods from scikit-learn library, and one such method is count vectorizer. It transforms text to frequency data, and below is an example of how it's done. This is another method called TF-IDF vectorizer. TF-IDF is term frequency inverse document frequency. It transforms text into a meaningful representation of numbers which can be further used to fit machine learning algorithms of prediction. This is a measure of originality of a word by comparing the number of times a word appears in the document with the number of documents the word appears in. And below is a formula to calculate TF-IDF.